Okay, so buckle up, because today we are diving headfirst into the world of Solana.
Solana.
It's this blockchain, right? And it's
Okay.
making some really big promises
Big, gold, ambitious promise.
about speed and scalability, things that, honestly, even as someone who follows this space pretty closely,
It's eye-catching.
yeah, it's eye-catching. It makes you kind of sit up and pay attention. We're talking thousands of transactions per second, maybe more, all while saying, hey, we're keeping it secure.
It's ambitious. There's no doubt about that.
So that's what we're going to unpack today.
Using their white paper, no
Yeah,
less.
Solana's own words.
We're going to look at their core innovations.
Like?
Proof of history,
Okay,
proof of stake,
got it.
proof of replication.
Yeah.
To see if they can really, truly deliver on what they're claiming.
Okay, so let's get granular here. Solana says it can handle way more transactions per second than something like, let's say, Bitcoin.
Right.
Where does that performance boost even come from?
Well, a lot of it comes from how they've approached timekeeping.
Timekeeping.
Yeah, within the blockchain. They call this proof of history or POH.
All right, proof of history, POH, sounds intriguing,
Yeah?
but maybe a little intimidating.
A little bit, yeah.
Break it down.
Okay. Imagine a blockchain that's like a high-speed camera,
Okay,
just capturing every single change
got it.
with a precise timestamp. But instead of light, it's cryptography doing the heavy lifting here.
So like a time-stamping machine on steroids?
Exactly. Solana uses something called a cryptographic hash function. So essentially, you feed data into this function, and it spits out a unique output,
Okay,
a string of characters that's virtually impossible to predict
got it.
or reverse engineer. And here's the real kicker. They feed the output of one hash back into the function as the input for the next one,
Oh, wow.
creating this continuous chain of these unique time-stamped outputs.
It's like a chain reaction.
It is.
Yeah.
It's like a verifiable timeline of every single event on the blockchain.
So it's like a built-in proof of when everything happened.
Yes.
That's brilliant.
Yeah.
But I'm not seeing how that makes things faster.
Right.
How does that connect to all these transactions?
So this is where it gets really interesting. Traditional blockchains need every single node on that network to agree on the order of transactions, right?
Mm. Right. It's like a consensus mechanism.
Yeah, it's very democratic,
Yeah.
but incredibly time-consuming. With Solana's POH, there's no need for that back and forth. Transactions are time-stamped, woven into this chain, and boom, near-instant confirmation.
Wait. So this proof of history, this chronological chain, that eliminates the need for constant consensus amongst all the nodes.
Precisely.
That's a game changer.
It is.
No wonder Solana is claiming these insane speeds.
And there's not even all of it, right?
There's more.
This innovation, this proof of history, really underpins their whole approach to security and data integrity.
Okay, color me intrigued, because we were just talking about vulnerabilities, right? Like, what if someone could manipulate the timeline?
Mm.
So how does Solana make sure that no one's messing with their fancy new clock?
Right, so this is where Solana's proof of stake, their POS system, comes in. Instead of relying on that energy-intensive mining like some older blockchains use, Solana uses a system where validators pledge their own coins as collateral to participate in securing the network.
So they're putting skin in the game.
Exactly. Think of it like a security deposit system for honesty.
Okay, I like it, but how does that actually work?
It all boils down to incentives. So validators get rewarded for validating transactions accurately and punished by losing some of their stake if they try to cheat.
Oh.
This creates a very strong economic incentive for all the participants to act in the best interest of the network.
So the more you invest, the more you stand to lose if you try to game the system.
Exactly.
That makes sense, but what happens if a validator goes offline?
Right.
Maybe one with a lot of stake. Does everything just grind to a halt?
That's a great question, and Solana has a clever solution for this.
Ah.
They have this really interesting election process where validators with the most stake are chosen to add the next block to the chain.
Right.
But it's not just about picking one leader.
They've got backups.
Yeah, exactly.
Okay.
Like an understudy.
That's reassuring.
Right.
And we all need a coffee break sometime. Even validators on a blockchain, right?
Exactly. Solana calls them secondary leaders,
Okay.
and they're ready to jump in if the primary one goes offline. Keeps the network humming along, even if someone, spills their latte on their hardware.
Okay, I'm starting to get a real appreciation for how Solana has thought this through. But let's shift gears for a second.
Okay.
From speed and security to something else that's equally important.
Data storage.
Oh, absolutely.
It's all very well having this super fast, super secure blockchain.
Right.
But we need to make sure that the information is stored reliably too, right?
Data integrity, paramount, yes.
Okay.
That's where Solana's proof of replication comes into play, or PoRep for short. Right, PoRep. It's about ensuring everyone on the network has the same information, right?
Well, not exactly.
Okay.
Think about it. Copying this massive, constantly growing blockchain to every single node
Yeah.
would be incredibly inefficient.
Yeah, talk about information overload.
Right.
It'd be like downloading the entire internet every time you wanted to check your email.
Exactly. So instead of everyone keeping a full copy, Solana uses PoRep to prove that the data is being stored correctly, without all the unnecessary bulk. They do this with a really clever combination of encryption and sampling techniques. Imagine taking snapshots of specific parts of the blockchain at random intervals. And as long as those snapshots match across different nodes, it's highly likely that the data is being replicated accurately.
So it's like a spot check system,
Yes,
but for massive amounts of data.
exactly.
Instead of checking everything, you're verifying enough to be confident in the overall integrity.
Precisely. And because these checks are woven into that POH timeline that we discussed earlier,
Right.
they become part of that verifiable history. Anyone can audit the process and see that the data is where it should be.
Okay, so PoRep just adds another layer of security to this whole system.
Yeah.
It's like having a tamper-proof seal on every part of the blockchain.
Right.
But how does Solana ensure these PoRep checks are happening quickly enough? I mean, we're talking about keeping up with all those transactions that they're processing.
Right. So this is where things get really innovative. These PoRep checks are designed to be incredibly fast, even with huge amounts of data. Solana leverages parallel processing, meaning multiple operations can happen simultaneously.
Hold on, are we talking about GPUs here?
You got it.
Like the ones in gaming PCs?
That's right. That same technology that helps render those stunning graphics can also be used to crunch through blockchain data at lightning speed.
That's wild. Okay, so with POH, POS, and PoRep, Solana is essentially weaving together timekeeping, security, and data integrity
Yes.
into this incredibly fast, potentially more secure, and decentralized system.
You've got it. You've hit the nail on the head. It's this really beautiful kind of symphony of cryptographic innovation, all working in concert.
Okay, I'll admit my head is spinning, but in the best way possible.
Chuckles.
This is light years beyond anything I imagined, but I do have to ask, are there any downsides to this approach?
Sure.
Because it all sounds almost too good to be true.
Right.
What are the potential pitfalls, the limitations that Solana might need to overcome?
That's the million-dollar question, isn't it?
Right.
And it's such an important one to ask with any emerging technology.
Oh, of course.
Right. While the white paper paints this incredibly impressive picture, we have to remember it's still a theoretical framework.
So real-world performance could be different from what's on paper. I guess that's always the challenge with this kind of cutting-edge tech, right?
It is. Bridging that gap from theory to practice, that's where the rubber meets the road.
Exactly.
And it all comes down to implementation, how Solana addresses potential vulnerabilities. In fact, even the white paper mentions some challenges.
Oh, really? Like what?
Well, they talk about something called ASIC resistance, for example.
ASIC resistance. Okay, I'm going to need a bit of a glossary on that one. What are we talking about?
Okay, imagine specialized hardware, custom built for a very specific task.
Sure.
So in the blockchain world, we talk about ASICs. These are machines designed for mining Bitcoin.
Right, I've heard of those.
Now, Solana wants to be way more decentralized than some of its predecessors.
Okay.
They don't want a world where only those with the deepest pockets and access to this expensive, specialized hardware can participate in securing the network.
Ah, so ASIC resistance is about ensuring a level playing field, keeping the power distributed, right?
Exactly.
Yeah.
But achieving true ASIC resistance.
Yeah.
It's tough, really tough. It's like a constant cat and mouse game. Developers are trying to build these open systems, but then you have hardware manufacturers who are constantly trying to optimize for specific tasks.
So while Solana's architecture sounds incredible on paper,
Right.
this whole ASIC resistance thing is a potential hurdle they've got to clear.
Yeah.
It's a good reminder that even with this seemingly revolutionary tech, the devil's often in the details.
I couldn't have said it better myself. And that's why we're here on the deep dive to break down these complex topics, explore the potential, sure, but also the pitfalls, and give our listeners the info they need to make up their own minds.
Absolutely. We've thrown around a lot of technical jargon today.
We have.
Proof of history, proof of stake, proof of replication, ASIC resistance. It's a lot. But what's fascinating to me is it's all interconnected.
It really is.
Solana isn't just about speed, it's about rethinking the entire foundation of blockchain
I
technology.
couldn't agree more. Their approach is all about striking that balance between, high performance, tight security, true decentralization. Whether they can pull it off long term, well, that's still an open question. But you can't deny the ambition, the ingenuity of their whole approach.
Well said, well said. It's like they've taken the best ideas from every blockchain that came before, added their own little twist, and said, hold my crypto, watch this.
Yeah.
As we wrap up here, one thought keeps coming back to me. We spent a good amount of time on this proof of history idea, this verifiable, tamper-proof timeline. It really gets you thinking. Beyond crypto, even, what else could we use this for? What other applications could this have?
Right.
Could we use it to track supply chains, ensure that voting systems are truly secure, maybe even create this permanent, unalterable record of historical events? The possibilities feel endless.
That's a fantastic point, and it really speaks to the potential of blockchain in general, right?
Yeah.
It's not just about digital money, it's about rethinking trust,
It's a
transparency.
digital world.
Exactly.
Well said. And on that note, I think we'll leave our listeners with that final thought. How could these Solana innovations, this idea of a proof of history especially, reshape not just finance, but our whole world, really? Give them something to chew on until our next deep dive.
Exactly. Keep those brain cells firing.
Thanks for joining us, everyone.
Until next time.